Okay, students. Now I will explain you some other questions of the Fourier transform. Okay. The example is third one. Example is evaluate Fs, that the Fourier sine transform inverse of this is p by 1 plus p square. Okay. Here in this question we using the Fourier inversion formula. Okay, which is fx is equal to f of s sine of Fourier transform inverse of f of sp. So this formula is 2 by pi 0 to infinity fsp sine p dx. Okay, you know this one. Okay, now fsp, which is given in your problem, is this is equal to 2 by pi. Okay, now 0 to infinity. Yes, and here is p by, the question is p by 1 plus p square, and according to sign, so sine of px dp. Okay, students, clear? Now, this is the, here we using Fourier inversion formula. Okay, now f of x, this formula or this can also be written as, if you multiply and divide on both sides, that is p multiplying here and again p multiplying here, then this become 2 by pi 0 to infinity, and here is p square by p into 1 plus p square sine p x dp. And now adding 1 and subtracting 1, so plus 1 and again minus 1. Okay, we can write this one. Okay, now if you dividing both two terms, then this become 2 by pi, 2 by pi, and here is again 0 to infinity. Okay, and the first term is this by this, that is sine px by p dp, and minus of 2 by pi, here become 0 to infinity sine px divided by 1 plus p square, and also p is also here is multiplied p dp. Okay, students, clear? Okay. Now, since we know the integral value of the sine px by p, we know this one. Since we know that, integral from 0 to infinity sine px by p dp, which is equal to pi by 2. We evaluate earlier. Okay, so this can be written as, so fx is equal to 2 by pi, and here is pi by 2 minus 2 by pi 0 to infinity sine px by p 1 plus p square dp. Yes, students, clear? Okay. So this is equal to, now let us suppose that f of x is, this is, if we suppose that this is I. Okay. Now we suppose that, or we can say, or differentiating if of f of this is, or we say that, let again f of x is this one. Now in next page I have defined you. Okay. In next page f of x is this one. Okay. So now df by, that is differentiating, df by dx, which is equal to, here you see, here is, let us here f of x is equal to, of this is if you suppose this equation is 1, here you see, if you differentiating this, then this term is cancelled out, and you differentiating with respect to x, so p is here again become, so you get this is equal to df by dx is equal to minus 2 by pi, yes, and 0 to infinity, and here is again, because you differentiating with respect to p, so with respect to x, so here is p cos px dp by p 1 plus p square. Okay student, p cancel out, yes, so you become this is equal to, okay, minus 2 by pi 0 to infinity cos px, yes, cos px, yes, this divided by 1 plus p square dp, yes, clear? Okay, this become you df by dt. Now again differentiating, if you, this is df by dx, okay, if you again differentiating with respect to x, okay, then you get d2f by dx2, which is equal to, yes, differentiation of cos px, you know the sign of this is, okay, so minus cancel out, so 2 by pi 0 to infinity, here is p sine, yes, px divided by 1 plus p square dp, yes, clear? Okay, let us suppose that this equation is differentiation of this is 2, and again differentiation, because here we make the solution of this is, you know, which is f, here you see, yes, this is equal to f is equal to, here you f of f is equal to 2 by pi of this is, okay, so this can be written as d2f by, yes, d2f p by, yes, 1 by p square, so this is can be written as d2f by dx2 minus f, which is equal to 0, or you get the solution of this equation, and the solution of this equation is f is equal to m square minus 1 is equal to 0, like that, m is equal to plus minus 1, that is a e to the power x plus b e to the power minus x. Let us, this equation number is 3rd. Okay students, now again differentiating, if this is solution, that is df by dx, then this become a e to the power x, here minus of b e to the power minus x. Again let us suppose equation number 4. Now when x is equal to 0, so f become, yes, from 1, yes, from 1, f is equal to g, this is equal to 0, then this 0 you get this is 1, that is f of x is 1, yes, clear? F of x is equal to, you get, which is, you get this is, yes, you get which is equal to 1. Okay students, now and again and df by dx and df by dx, which is equal to, yes, minus of 2 by pi, and which is 0 to infinity from equation number 2. Yes, this is from 1 and here is from 1 and this is from 2, you see. Yes, 0 to infinity 0 cos px, that is 1, that is dp by 1 plus p square. Okay students, this is the integration of this is, you know, the tan inverse of p, that is tan inverse of infinity, that is pi by 2, that is you get this is minus of 1. Yes students. Yes, I think you have clear. Okay. Now from equation, yes, now df by dx is you get minus 1. Okay. So from equation number 3 and 4, so from equation 3 and 4, substituting the values of these according to f is 1 and according to this, when f is 1 then a e to the power, yes, and here is a, and x is 0, so 0 of this is plus b to b e to the power minus of 0 or 0 you say, which is equal to 1, or we say that a plus b is equal to 1, and from 4 a e to the power 0 plus b, sorry, minus of b, minus b e to the power minus 0 or 0 which is, or say which is equal to minus of 1, or a minus b is equal to minus of 1. Yes, solving these equations, yes, solving we get, yes, solving we get, yes, 2a is equal to 2, yes, yes, a, and adding this equation then a is 0, subtracting this equation then b is equal to again 2b, which is 2, that is 1, yes, b is get 2b, which is 1. So substituting, yes, so hence f(x), hence fx is equal to a is 0, b is 1, so e to the power minus x, actually from 1, hence here the result is from 3. Yes, so the result is f of x. Yes student, I think you have cleared this question, that is this, here the question is inversion, here you using the inversion formula. Okay, thank you. Next video I have explained you some other questions. Okay, thank you.